We've talked about domain and range from graphs, from tables, from, what else? Ordered pairs and mapping. So today we're going to talk about domain and range in a situation. This is called reasonable domain and range because we've got to figure out what the X value is, or the input, the domain, and what the Y value is, the output, the range, and then what would be reasonable in this situation. So it helps if you write the equation. Now, this says function. We haven't learned function notation yet. We will tomorrow. But for today, let's just write it as a y equals. Okay, she's selling candles as a fundraiser. She spent $50 on supplies. So she's kind of at a negative 50 right now because that's how much she spent on supplies. She plans to sell the candles for $10 each. So I would represent this situation with y equals, well, she's making $10 per candle. X is going to be the number of candles, and that's your unknown. And y, and then you've got to, if you're talking about her profit, how much she's going to make, you've got to take away the 50 she spent on supplies. So the X is representing number of candles, the Y is representing her profit. Is this discrete or continuous? That's our first decision to make. So can you count these things? Can you count them with whole numbers? 1, 2, 3, 4 candles. You can't sell half a candle. You can't sell 3/10 of a candle. Therefore, it's countable. It's separate points. It's discrete. I'm not going to make you write that. We'll just circle it. So what's the domain? If the domain is number of candles, and you can't sell part of a candle, but also can you sell negative candles? No. Could she sell 0? Yep, she might sell 0. She could sell 1, 2, 3, 4, etc. And you can't list the total number of candles, so you just need to establish the pattern. If you establish the pattern, then you can put the ellipsis there to show that it keeps going in the same pattern. Now the range. The range would be the Y, the output. In this situation, it represents her profit. Well, she makes $10 a candle, so it's going to go by tens, right? But what did she start at? She started at a negative 50. Then when she sells a candle, she's made up $10 of that. Then she's made up another 10. Now, can she sell 0 candles? Yes. I think we've established a pattern. So I just wanted you to see what can happen. Her profit, she starts in the whole $50, but every time she sells a candle, she gains $10. How many candles does she need to sell to start making a profit? Well, when does she start making a profit? It's when she gains this back, right? So 10x minus 50 has to be greater than 0, doesn't it, for her to make a profit? So let's solve that, don't you? Her profit needs to be more than 0. So let's say add your 50, 10x is greater than 50. Now we divide by our 10, and x is greater than 5. So how many candles? She needs to sell more than 5, so she needs to sell at least 6 candles to make a profit. Now let's look at another one. Look at Macy's throwing a party. The caterer charges $60 per person. 15 guests have been invited, but they might not all attend, and assume that at least one person shows up. All right, first let's represent our function. So what do you think the input is? The output, the domain, the range. Independent, dependent. What depends on what? Well, doesn't the cost she's going to pay, that's your Y value, the total cost she's going to pay, doesn't that equal $60 per person, where X is your number of people? So the domain is your number of people, the range is your total cost. Is this discrete or continuous? Well, can we count them? 1 person, 2 people, 3 people, 4 people, etc. You can't have part of a person come to the party. So it's got to be whole numbers. It's countable. It's discrete. So if the domain, if X is the number of people, but at least one person shows up, we've got to start with 1, 2, 3. But how many have been invited? 15. So the most that can possibly come is 15. Since you've established the pattern, you don't have to list them all. You can put the ellipsis there. Whoops, an ellipsis really is just 3 dots. And show that the most is 15. So the range is her cost. Can her cost be 0? No, because at least one person shows up. So when that one person shows up, it cost her $60. But then she adds 60 for each person. So her cost could be, now, what can her total cost be? She's not going to have more than 15 people at the party. So 15 times 60 is $900. So the most she's going to pay is $900. That's an expensive party. I hope they're eating steak. Would it be possible for the caterer to charge her $750? Well, there's a lot of ways you could do this, but I'm going to substitute for Y. Can the cost be $750? Well, if you divide this by 60, does it come out to a whole number? Well, no, it doesn't. It comes out to, let's see, 12 point, I think something there. I'm just doing the math in my head. So it comes out to 12 point something. So no, it wouldn't be possible because it's not divisible by 60. So it wouldn't be possible because it's not divisible by 60. Let's look at the last one. Tristan's driving from Sanger to New York City at an average speed of 60 miles per hour. It will take him about 30 hours to complete his drive. So first, let's write the function. So the total number of hours it takes him, total number of miles, total number of miles equals 60 miles times each hour. Is this discrete or continuous? Does Tristan drive 1 hour, 2 hours, 3 hours, 4 hours? Well, no, he can drive part of an hour. He can drive an hour in 3 minutes. He can drive an hour in 3.5 minutes. So yes, this is continuous because it keeps going and it continues. It includes parts of an hour and parts of a mile. You can also do part of a mile. So if your domain is your number of hours, can he drive negative hours? No, that makes no sense. But he can drive 0 hours and he can drive 30. So your domain is greater than or equal to 0 and less than or equal to 30. Because this is continuous, it's not countable. It's not discrete points. If we graphed it, it would be continuous. Therefore, we represent it with the inequality. We represent continuous domain and range with inequalities. So what's the range? He can't drive negative miles. That would not make sense, but he can drive 0 miles. Or what's the most he could drive? Well, 60 miles an hour for 30 hours, that would be the most he could drive, 1,800 miles. So Y is between 0 and 1,800. Would it be possible for him to drive 1,455 miles? Well, let's divide. It's less than 1,800, and it doesn't have to be perfectly divisible by 60 because it's continuous. So as long as it fits within here, we don't have to worry about whether it's divisible. So yes, because it is less than that, and he can do it in less than 30 hours. So there's just a few examples of of reasonable domain and range.